Welcome to the class Quantum Mechanical Model of Atom. What it considers, what is the importance of quantum mechanical model of atom? From the previous classes we know Bohr model has failed and then Heisenberg uncertainty has come out, and from Heisenberg uncertainty and dual behavior of matter a new concept is developed, quantum mechanical model of atom. Okay. What is the importance of quantum mechanical model of atom? Okay. In classical mechanics, classical means old theories. Classical means old theories. Old theories as dealing with the macroscopic particles. Those laws are for bigger bodies. They cannot consider the smaller bodies like electrons. Okay, and moreover they also ignores the dual behavior of the matter. Okay, old theories that is known as classical mechanics ignores the dual behavior of the matter, whereas the quantum mechanics has its own significance. It considers dual behavior of the matter, and as well as smaller particles like electrons. Okay, it consider microscopic objects. Okay, and this quantum mechanical model can applicable to smaller particles as well as bigger particles also. That is the reason why quantum mechanical model of atom or quantum mechanics is familiar or famous, because it consider macro objects and micro objects, whereas classical laws only applicable to macro bodies only. That is the reason why quantum mechanical model of atom has some significance. Okay. Quantum mechanical model of atom. In quantum mechanical model of atom, okay, how it is developed? Heisenberg and Schrodinger have independently did their studies, and then now we are discussing Schrodinger wave equation. Okay, Schrodinger wave equation. What is the meaning of Schrodinger wave equation? How it has come into the light? Okay, we know in a particular atom electron is revolving around the nucleus. We know electron has dual behavior. From the de Broglie concept we know it has a dual behavior. Okay, has wave nature and particle nature. It has a wave nature. Electron has wave nature. We know the wave like this. Okay, electron has wave nature. For particular type of wave, we have to study it in the form of mathematical terms, psi. Okay, psi. Okay, psi is a mathematical term. Okay, psi is a wave function. This is known as wave function. Psi is a wave function. Psi is a wave function. Okay, psi is a wave function. Okay, next, psi is a wave function. Okay, electron has wave nature. That is the reason why this wave, we are studying that wave as a wave function, mathematical wave function. If we operate something operator in this, okay, we operate something on this wave function, you can get the type of results. Let us take it an example. There is an operator this is an operator, mathematical operator, derivative. This is a mathematical operator which is operated on psi. Okay, you can get something results. Okay, something the result, and then get the wave function. Okay, let us take an example. Let psi is equal to e to the power of 2x. Example, if the mathematical wave function psi is equal to e to the power of 2x, then we did an operation d by dx on 2x. You can get the value 2 into 2x. It means 2 into psi you can get. Finally, you may write like this: d by dx psi is equal to 2 psi. You can get this type of result. Okay, here the value 2 is known as eigenvalue. This is known as eigenvalue. EIGN, eigenvalue. This psi is known as eigenfunction. This is known as eigenfunction. Eigenfunction, eigenvalue. Okay, this is known as eigenvalue. This is known as eigenfunction. So some operators may differ. Now I am operating d by dx on wave function. We can get some value and the wave function. That value is known as eigenvalue. That wave function is known as eigenfunction. Okay. Let us take another way. Hamiltonian operator is operated on a wave. You can get energy and wave function. Is known as Hamiltonian operator is operated on a wave function. You can get the values and the wave function. Okay, this is known as Hamiltonian operator. Hamiltonian operator. This is known as Hamiltonian operator. Okay. This is energy operator. Here the wave function from the electron. Let us take this wave function from the electron. The wave operator is Hamiltonian operator. This is known as total energy operator. This is also known as total energy operator. Total energy operator is operated on a wave. You can get the value, energy value and the wave function. Okay. This value is known as eigenvalue. This function is known as eigenfunction. You may treat it as. Okay. From this you can derive Schrodinger wave equation. Now what we are doing right now is using this concept is the energy operator is operated on a wave function, and you can get this something results on the wave. Okay, wave function and the wave function. Okay, this from this point of view you can get the Schrodinger wave equation. Let us see it. Okay. Hamiltonian operator is written as like this: minus h square by 8 phi square m dou square by dou x square plus dou square by dou y square plus dou square by dou z square plus v. Okay, let us substitute here this one in this. Let us substitute this one in here, and you can get like this: h square by 8 phi square m dou square by dou x square plus dou square by dou y square. Okay, this is minus. Okay, plus dou square by dou z square. Okay. Into V psi is equal to E psi. Okay, this is substituted here, you can get these results. Then consolidate this one, this equation. Let us simplify this equation. Then you can get the Schrodinger wave equation. Okay, on simplification, you may get like this. Let us multiply with negative sign. Then you can get on multiplication with minus negative sign. Then it is get positive, and this is get negative, and this is get negative. Okay, negative, it is converted as negative sign. Okay, next let us consolidate it. Dou square psi, you may write like this, by 2x square plus dou square psi by dou y square plus dou square psi by dou z square, and then we 8 phi square m by h square. Okay, you may like this. This is multiplied like this, and then you may get 8 phi square m by h square e psi. Okay, you may get like this, because we know the concept h psi is equal to e psi. Okay, from that consolidate, from bring this one from equation outside to inside, then you can get dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. From here 8 phi square m by h square. Okay, h square, and then you can get e. Okay, e minus v psi is equal to 0. Okay, from the consolidation you get this equation. This is known as Schrodinger wave equation. In many examinations they may ask you, what is the Schrodinger wave equation? Schrodinger wave equation is like this, e minus v. Okay, this is known as Schrodinger wave equation. Okay, let us understand this equation, what we get and what we did. Okay, let us see it. This is known as Schrodinger wave equation. We know h psi is equal to E psi. This is the operator, total energy operator is operated on a wave function. You can get this something, the results, and you can get the wave function. Okay, whatever results you are expected, you did the some operation and you can get the type of results. This is energy operator, so you can get the energy results. So from this Schrodinger wave equation, just now we write here, from the Schrodinger wave equation you can get the results. You can get the results. The results are energy levels. The results are energy levels, E1, E2, E3, quantized energy levels you can get. Okay, these energy levels, each energy level has wave function. Okay, this energy one, the solutions are like this. From this equation you can get the Schrodinger equation. Schrodinger equation gives the results. The solution of this form is energy 1, E2, E3, like that you can get. Each one has the wave. Each one have the wave functions. Each one have the wave function. The solutions of this one is wave functions. You can get it. Okay, this one is E1, this one is E2, E3, energy levels, quantized energy levels, and each one has the wave functions like this. These wave functions are identified by these wave functions are distinguished by the quantum numbers. These wave functions are distinguished by or characterized by quantum numbers. Quantum numbers are used to distinguish these wave functions. So these quantum mechanics or quantum numbers are used. Quantum numbers are used. Quantum numbers are used to characterize the wave functions. Characterize the wave functions. Or distinguish, whatever it may be, the terms are very much similar. Okay, quantum numbers are used to characterize the wave functions. Okay. Finally, what we know, psi is a wave function. Orbital wave function. What is the means of atomic orbital wave function? Atomic orbital wave function. Whereas psi square, okay, modulo of psi square represent atomic orbital. Okay, these are the differences between these two. Okay, this is the basic idea for the development of the quantum mechanics. Okay, these are useful for single electron containing atoms. For multi-electron containing atoms, it is a difficult one. There is various methods are present in the quantum mechanics. So the Schrodinger wave equation for single electron containing atoms very easy, but it is more difficult for the multi-electron containing atoms. Okay. Important points. What are the important points in quantum mechanics of atom? Okay, energy of electrons in atoms is quantized. Energy of electrons in atom is quantized, is fixed. Quantized means fixed. Okay, at a particular level, okay, if an electron present in a particular level, its energy is fixed. That is known as energy of electrons in atoms is quantized. Second point, the existence of quantized electronic energy levels is direct result of the wave-like properties of electrons. Okay, the existence of quantized electronic levels in an atom is a result of the wave-like properties of electrons. If the electron has wave-like motion, from that only you can get the quantized electronic energy levels in an atom. Next, third point, we know the exact position and exact velocity of an electron in an atom cannot be determined simultaneously. Okay, this is known as Heisenberg uncertainty principle. Okay, you cannot determine position and velocity of an electron in an atom cannot be determined simultaneously. One talk only probability of finding an electron. Okay, we talk from this concept Heisenberg uncertainty principle, we understand probability of finding an electron, that new idea will come out. Next, fourth point, the atomic orbital wave function psi, atomic orbital wave function psi represents state of an electron in an atom. Okay, state of an electron in an atom is represented by the wave function atomic orbital wave function. Atomic orbital wave function represents state of electron in an atom. Okay, how the electron is present. Next, fifth point, psi square represents probability density OR orbital. Okay, psi square represents probability density OR orbital. Okay, these are the important conclusions are drawn from the quantum mechanical model of atom. Okay.